Hello, calculus students, and welcome to 3.4, the second derivative test in concavity. And this video is going to describe to you what concavity means and how to determine if something is concave up, concave down, and what that means in the scope of a function. So we're going to start off pretty simply here with just the graph of a function here. And I want you to ask yourself, is this graph concave up? Is it concave down? Is it both? If it's both, when does it switch from concave up to concave down? And what does that really mean? So think about those questions for a second. Stop if you need to. This function from here to here is concave up. Something happens at this point where it changes concavity, and now it's concave down. And you imagine it as concavity is, or a change in concavity is where one hill ends, where one valley ends and the hill begins. And so if you imagine this, you've got a valley here. And at some point, it stops becoming the valley and it starts becoming the hill. And that point at which it changes is a point of concavity, all right, where we change concavity. And so imagine concave up is like a bowl, concave down is like an upside down bowl, and where it changes, that's where you change your concavity. Another way to think of it is with mini tangent lines. So I'm going to go around here and draw some mini tangent lines along this function. And you can see my mini tangent lines at these points stay pretty much below the function until you get to a certain point where your tangent lines start to be above the function. And so from here to here, all my tangent lines are below the function. And then you get to a point somewhere where your tangent lines change from below the function to above the function. That change is also a spot where there's a change in concavity. It happens right about here, where we change from concave up to concave down. So here's sort of a formal definition for concavity. If f is differentiable on the open interval I, the graph of f is concave up if f prime is increasing, and concave down if f prime is decreasing. And so what we're talking about now is sort of like the slope of the slope. All right, if f prime is increasing, which means the derivative of this is increasing, then we're going to be concave up. If f prime is decreasing, which means the derivative of this is decreasing, that means we'll be concave down. So you kind of have to imagine, what's the slope of the slope going to be? And is that going to be positive or negative? Because that can determine what your concavity is going to be. All right, so here's a chart that may be of some use to you, some help. If a function looks like this, I want to know, what is the sign of f prime of x? Is it going to be positive or negative? Same thing with this function, and this function. So take a second, fill those in, positive or negative for all the four in this top row. Also fill in what you think the sign of the second derivative is going to be. So if you need a second, pause it, fill those in, and then we'll fill them in together in just a second. All right, so this one is increasing, so we know we're going to have a positive slope. Same thing with this one, it's increasing. Then we have something that's decreasing and something that's decreasing. So those are the signs of the first row there. Now we're going to go to the second row. A couple different ways to look at this. You can look at it as our definition earlier. If the derivative is increasing, then it's concave up, derivative is decreasing, then it's concave down. And we're going to see if that has any effect on what these signs are going to be. All right, so what you need to ask yourself is, this is increasing, but is it increasing at an increasing rate, or is it increasing at a decreasing rate? Which is like, it's getting bigger, but is it getting bigger faster, or is it getting bigger slower? And that's the main question. In this one, it's getting bigger, it's definitely increasing, and the slope itself is also increasing. So it's increasing an increasing rate. Which means that the sign of my second derivative must be positive because the slope is getting bigger. So the slope is changing at a positive rate. This one is increasing, but the slope is getting smaller. Still positive, still increasing, but the slope is getting smaller, which tells me that the sign here is going to be negative because we are increasing at a decreasing rate. All right, see if you can fill out the next two if you haven't already. This one here, our slope is negative. We are decreasing and the slope is becoming even more negative. And so what that tells me is that my slope is getting smaller or more negative as I move along it, which means this is also going to be negative. Okay, because my slope is decreasing and it's decreasing even faster. And then here, my slope is decreasing, but the actual values themselves are getting bigger because the slope is really negative here, less negative, less negative, less negative, less negative. And so it is positive. Okay, and I would call this decreasing at an increasing rate. Okay, it's getting more negative, so I would say it's decreasing at an increasing rate. And this one is decreasing at an decreasing rate. It's getting smaller, but it's getting less smaller. All right, and so what do we conclude from this? And here's the idea. We've got these functions which hopefully we can tell if they're concave up or concave down. This one here is concave up. This one's concave down. This one's also concave down. This one's concave up. All right, and you could tell by just saying, all right, if I finish the rest of my bowl, it's an upward bowl. This one's a downwards bowl. This one's also a downwards bowl. This one's an upwards bowl. So we have concave up, down, down, up. Notice the signs of the derivative. Second derivative here is positive with a concave up function, negative for the two concave down functions, and positive for the other concave up function. So the conclusion that we can come to here is that whenever we have a positive value for our second derivative, we're going to be concave up. Whenever we have a negative value for our second derivative, we're going to be concave down. And this is called the second derivative test. And there you have it. Okay, so that's the end of this video. This is just the first part of 3.4. So I'll post a couple more videos and you can check those videos out and determine how to do the second derivative test. So have a great night.